Okay, our number 3, point A and B are 100 feet apart. Point A is 20 feet above the x-axis. Point B is 60 feet above the x-axis. What is the shortest distance from point A to point B if you must touch the x-axis? So I'm saying, if you can visualize the problem, that would be a good place to start. So let's take a look at that. I want to see if I can visualize what they said. All right. Now I'm going to put an xy axis down, and I'm going to put A right here. And if A is 20 feet above, this is A, it's going to be 0, 20. And then this guy over here, I want to point out, is going to be B, and B is 60 feet above the x-axis. What I don't know, I'm sorry, it's not, the x not 60, my mistake. I'm going to say there's a value x there, and we'll go through that, by the way. And then this is going to be 60. Now, what I want to do is I want to find out what the x-coordinate is there. And let's go through that. I'm going to use Pythagorean theorem. And the question is, I got to go back and read the question. I just forgot what they said. I think they said they're 100 feet apart. Let me just go back and make sure they did say that. Yeah, they're 100 feet apart. So this distance over here is 100. So let me write down the distance formula for you. So it's going to be 100 squared is equal to, this is B, by the way. It's going to be, whoops, I got to be quick on this problem. My battery's going dead. Got 10% left. So it's going to be x minus 0, which is x squared. Plus, well, let's see, 60 minus 20, that's going to be 40 squared. And I'm going to say 100 squared minus 40 squared is equal to x squared. I'm going to, my arithmetic may look different than yours. I'm going to say 100 minus 40, 100 plus 40 equals x squared. I'm trying to figure out x, by the way. This is going to be 60. This is going to be 140. That equals x squared. I'm going to factor out a 10 from the 60, a 10 from the 140, which is 100. I would get 6 times 14 is x squared. Next thing I'll do is factor a 2 out from the 6 and a 2 out from the 14. I get 100 times 4, and I get 3 times 7. That's x squared. And you may wonder why I'm doing that. I want to take the square root of that. I know it's a positive. I'm looking at my picture. So it's going to be 10 times 2, which is 20, and then the square root of 21, and that's what x is. So I'll put this down for you. Get my eraser out. I'll erase this over here. I'm going to put that number down now. And that number is going to be 20 root 21. Not a very pleasant number, but it's a number I can deal with. Now, what are they going to do? They're going to take a point on the x-axis that I need to touch, and I need to go there, and then I need to go back up here. And I'm going to call that point x. I don't know what it is, by the way, but I do know the x is between things. It's between 0 and it's between 20 root 21. I know that much. So what do I got for the y? The y is 0. All right, so we got this part done. Now I'm going to write the distance now, and the distance for this thing, which I want to minimize, let's write this over here, the distance. I'll point out what the distance is, this guy here and this guy over here. I need to minimize that. So the first distance is like, x minus 0. I'm just going to say x squared. Plus, the next one's going to be 20 minus 0, or 0 minus 20, depending on how you look at it. I square that, and that would be 20 squared. Plus the other guy's distance, more complicated. What's that going to be? Let's see, 20 root 21 minus x squared. And 60 minus 0 is just 60, so 60 squared. And this is a function of x, by the way, and I want to minimize it. How do I do that? Well, this is a function of x. To minimize this guy, I'm going to take its derivative. And let's take a look. And you get 2. You get the root x squared plus 20 squared. The root of the inside is going to be 2x. What do I know now? Those 2's disappear, which makes it kind of easy for me. So this 2 cancels this 2. Let's go to the next guy. I'll write that down for you. Plus, it's going to be, let's see, 2, the root. I know it looks bad. I'm just writing it down, by the way. 20 root 21 minus x squared plus 60 squared. I go to the inside and take its derivative. It's going to be 2, and then 20 root 21 minus x to the first power, and then times minus 1. Right. I'm also going to reduce that, by the way. So the 2 cancels, And I'm going to just make a subtraction problem out of it. All right, so I'll take this over here and write minus down. I'm also going to erase the parentheses at this point. And what am I basically looking for? I'm looking for the x value that minimizes this. And I know my region of interest is going to be between x from 0 up to 20 root 21. So my problem comes now is, can I figure that out? And I think so. And by that I'm looking at when does it equal 0? I'll write this down. It's going to be when x over the square root of x squared plus 20 squared is equal to 20 root 21 minus x. And at the bottom you get this root problem over here. And it's problematic, I know that. I realize these numbers are not the most pleasant thing to look at. They're even hard to keep copying over and over again. All right, so I think I did okay there. And, what am I going to do now? I don't know, looking at that, I think I'm going to square both sides, get rid of those roots in the bottom. And you would get x squared. On the bottom you get x squared plus 20 squared. And then you're going to get equal. Let's see, this is the tough part. You're going to get 20 root 21 minus x squared. On bottom, you just get 20 root 21 minus x squared plus 60 squared. And this is the part where I'm saying, do I really want to do a lot of work over here? I'm looking to make it simpler. So what I want to do is I'm going to say x squared plus 20 squared. And what I'm going to do for this guy over here is divide the top and the bottom by this thing here. And if I do that, I get this. I get 1 plus 60 squared over 20 root 21 minus x squared. And that does look awful, doesn't it? So what I want to do now is take the reciprocals of each side, and you get x squared plus 20 squared over x squared. That's a reciprocal, by the way. Well, the reciprocal of the other side is pretty simple. It's just simply 1 plus 60 squared over 20 root 21 minus x quantity squared. And what I'm going to do now is subtract 1 from both sides. And that doesn't look bad to do, by the way. And what would you be left off if you did that? You may have to take a moment to think about that. You'd be left off with 20 squared over x squared is equal to 60 squared over 20 times root 21 minus x quantity squared. And like squares all over the place. So what I'm going to do now is, and again, I'm pretty comfortable, manipulating this thing pretty quickly because I know this is going to be held over here. All right, at least look at my picture. So what I want to do is take the square roots of both sides. And it looks relatively simple to do. And not plus or minus, by the way. It's going to be 20 over x is equal to 60 over 20 root 21 minus x. And what I'm going to do now is take reciprocals again. I get x over 20 equals 20 root 21 minus x over 60. I'm going to multiply both sides by 60 now. I get 3x is equal to 20 root 21 minus x. I'm going to add x to both sides now. I get 4x, 20 root 21. I'm going to divide both sides by 4 now, and I get 5 root 21. All right, so I'm saying that what did I just do? I just found an x that produces a 0 in the problem. Now looking at it, I know where this thing would be undefined. It would be undefined at numbers that create problems in a radicand, but I'm not really worried about that, to be honest with you. And I'm going back up here, and I found the x to be 5 root 21, and then 0 there. So that would be the path I'd have to take, by the way. And my question is, I want to go back and read the question to you, and I want to be clear about it. It says, what's the shortest distance from point A to point B if you must touch the x-axis? I think I found the shortest distance. If you want, you can analyze the derivative point. I'm pretty comfortable that that's a minimal distance over here, but I do need to write the distance down now. And the distance from up here is right over here. All right? Now, granted, let's write it down. And it's problematic. I know that arithmetic's killing me. And what I'm going to do over here, plug the number in. And it's going to be f of, it's going to be 5 root 21. All right, let's write this down. So it's going to be equal to a root, and I got to square that number. So it's going to be 25 times 21 plus 20 squared, which is 400, plus, let's put this down, and let's see, 20 root 21 minus 5 root 21, which can be 15 root 21. And I need to square that, all right? And then plus 60 squared. Now, by the way, I'm not going to go through the arithmetic, but you could. And what I mean by that, I would do the arithmetic, by the way, but right now, getting low on battery, I'm going to say do the arithmetic over here. And this number here should turn out to be, approximately about 160, all right? But anyway, in my answer key, I have it down for you. I'll show you that. At least I believe I have it written down for you. Let's go for this over here. And you should be looking at the keys, by the way. I know this is a tough problem, and I didn't go through all it. I actually, there's a little bit more work over here. I was using a closed interval method, but for the most part, I was kind of low on battery and was trying to get there. And it's an evaluation, by the way. And what's the problem with evaluation is actually doing it. I would say over here, it's probably sufficient to know that's an evaluation problem, and just do the evaluation. Again, use calculator if you need to. Thank you.